We are now going to be looking at the very final learning intention of the topic/the year. So this is I can solve problems with proportions and probabilities using the normal distribution. So I mentioned this a little bit in our last learning intention, and this was all to do with the standard deviation. So it was a really interesting, well, you guys might not find it interesting, but I do. But statisticians a long time ago noticed a particular shape that kept on coming up over and over again as they began to look at different data and start comparing them with each other. And they noticed that this very particular bell shape that occurred time and time again. And they decided to call this bell curve the normal distribution. And it has some very key features that we can use to help us solve a few questions around different data sets. So with our normal distribution, it has this symmetric bell curve, as we can see here. The mean and the median are always equal, and they're always located at the very center. So you can see here I've got mean, or I guess that could be the median too, depending on what the question gives you. We have that 68% of data, so that's around here, this 34 plus 34 here, always falls within one standard deviation of the mean. So you can see here next to my 0, I've got -1 and +1. And what these represent are standard deviations away from my mean. So this can differ from being as little as 1 to 10 to 5 to 500. It's whatever the question's giving you, whatever you've calculated yourself for that particular data. If I'm two standard deviations away on either side, so going from my -2 to +2, then this falls within 95% of the data falls within this range here. And then finally, if I'm within 3 standard deviations, so from this -3 all the way up into this +3, I am within 99.7% of my data that falls along this really big range here. So when you start doing these examples down below, you will see how we can use all of these percentages here to help us solve different questions. Another thing to have a think about and look about with our standard deviations is, not our standard deviations, our normal distributions, they're different shapes that they can have, so the different spread. So thinking about those standard deviations, like I said, if they are a really small standard deviation, you may have this really narrow distribution, as opposed to if you had a standard deviation that was a lot larger, then you're going to have a lot more of a broad distribution. But I wouldn't worry too much about this. But in case you were wanting to do, like, I guess, a direct comparison, if you were drawing two normal distributions on top of each other and making the standard deviations a bit more proportional, then this is probably what you'll find occurs. Of course, as well as our normal distributions, we've also got something called the inverse normal. It's not as scary as it sounds. It's really just a way to work backwards from a known probability to find the mean, standard deviation, or our values. And don't worry, we will be using a graphics calculator to help us find this. You're not expected to do this by hand at all. And then yet again, down the bottom, we've got a few calculator instructions here as to how to find our standard distribution as well as our inverse normal. These I will be showing you an example of when we go through the examples below. This question is asking us to look at the diameter of a trunk of a certain variety of pine tree, and it's normally distributed with a mean of 150 centimeters and a standard deviation of 30 centimeters. So the very first thing it's asking us to do is to sketch a normal curve that describes this distribution. So this normal distribution curve, we are going to use the base of the one that is in our notes. So we need a line that's approximately in the center. I hope that's in the center of my line. For yourself, hopefully you are making sure that you are making it as accurate as possible. Then, of course, from the normal distribution curve that you have in your notes, it has like the 1, 2, 3, and then it's got the -1, 2, and 3. Again, they should all be evenly spaced from each other, but I do not have a ruler to do so. Now, instead of the 0 it has in the center, you should have your mean of 150 centimeters here instead. So here's my center, and I've got 150. And instead of the 1, 2, 3 and the minus 1, 2, 3 on either side, this should be your standard deviations. And we've got that standard deviation of the 30 centimeters. So in this case, I'm not just putting 30 here. I'm actually going to add 30 onto 150. So this should be 150 plus 30, which is 180, plus a further 30, which gives me 210, plus a final 30 that should give me 240. Then going back the other way, we've got 150 minus 30, which will give me 120. Minus a further 30 gives me 90. And then finally, I've got 60. Now, you need to try and draw that normal distribution curve. And yes, it is very difficult to do so. So I usually try to draw a point at the very top so I know where the point of my curve is, and then try to make that kind of classic bell curve here. And then going back down the other way, that way was not nearly as nice. And then what I do to finish it off is that I'll draw nice ruled lines down to each of my key points here. So, like so. Hopefully yours will be done with a ruler. And just to help me out, I always fill in the numbers for each. So this is 34%. This is also 34%. Followed by 13.5%. And then we're looking at 2.35%. And then 0.15%. And then on the other side, we're looking at the exact same thing. So 13.5%, 2.35%, and I can't quite fit it in, so I'm just going to do a little arrow, 0.15% here. So definitely having all of the numbers written down and everything in your normal distribution curve is going to help you a lot when it comes to answering the questions that are down below. So for my first question down here, it says approximately what percentage of these trees have a diameter greater than 210 centimeters. So looking at my normal distribution curve that I've created here, I'm looking at my 210 and it's greater than, so I'm looking at this side of my normal distribution curve. So the percentage is going to be 2.35 plus 0.15. So 2.35 plus 0.15 should give me 2.5%. So this is the percentage of trees that has a diameter greater than 210 centimeters. Moving on to our next question down here. It asks me approximately what percentage of these trees have a diameter between 90 and 215 centimeters. Now, having a look, I could easily do the 90. However, there is no nice 215. It's somewhere in between the 210 and 240, but not quite. However, what I can do is use my graphics calculator. So if I go to menu, stats, get out of all that, I need to go where it says dist, which stands for distribution. I then go to where it says norm, and I need to go where it says NCD. Now, for this case here, my lower is 90, and my upper is 215, as I've already put into the graphics calculator. And then my standard deviation, I believe, is not 5. It is, in fact, 30. and my mean is 150. Go. And now I go down to where it says execute. And here we go. It says that the probability, so the P, is equal to 0.96. So in the context of my question, it's my percentage of trees that have a diameter between 90 and 215 centimeters is approximately 96.2. So approximately 96.2%. And this makes sense looking at this, because if I'm looking from between 90 to 215, that is a... Now, applying this normal distribution to an actual, I guess, number of trees, we're still going to use our normal distribution curve to help us answer this, but instead we can now apply it to some number. So in this case, it says a section of forest has 500 of these trees, and it's asking approximately how many of these trees have a diameter smaller than 120 centimeters. So I need to go back up to my normal distribution curve and then have a look at this lower this lower part of my normal distribution curve that's less than 120, and add up all of the percentages under this 120. So this would be 0.15 plus 2.35 plus 13.5, which I believe should give me 16. Yep. So adding this down here, I'm going to have 0.15 plus 2.35 plus 13.5, which is going to give me 16%. And we know that the trees should have a normal distribution. So if we're looking at 500 trees here, I'm going to have 500 multiplied by 0.16, or 16%. And this is going to be equal to 80. So therefore we've got that there are approximately 80 trees with diameter smaller than 120 centimeters. The very last part of this question is asking approximately how many of these trees are between 120 and 180. So again, looking back up to my normal distribution curve to where I'm between 120 and 180, I've got 34 and 34. So the percentage that I'm looking at is going to be 34 plus 34, which is of course 68%. So of my 500 trees, I need to have 500 times by 0.68, or 68%. And putting this into my calculator gives me 340. So I've got that 340 trees. We are going to be looking at the final question for our examples here. And this is some examples of our inverse normal distribution questions. Now, just to quickly show you how I got here, I went to the dist part, still looking at normal distributions, but instead of our NCD, I pressed the INVN for our inverse normal distribution. Now, the first question asks us about what amount of time do the bottom 20% of teachers work if I've got a normal distribution of 20 hours and a standard deviation of 5 hours. Now, because I'm looking at the bottom 20%, if we go up to my normal distribution curve here, the bottom is when my tail is, of course, to the left. So I've got a left tail here. And I've got an area of 0.2, so 20%. My standard deviation, as I said before, was 5, and my mean is 20. And I want to go down to, of course, where it says execute. And in this case here, it tells me I've got a normal or inverse normal distribution, I guess, of 15.8. So in the context of this question, the amount of time the bottom 20% of teachers work is 15.8 hours. Looking again at now my top 20% of teachers. So if this meant that my tail was to the left for my other one, that means I now need my tail to the right because I'm looking at the top 20% if we were to look back at our normal distribution curve diagram. Everything else is still the same though, so I'm going to go to where it says execute, and in this case here it says the top 20% of teachers work 24.2 hours. Oops, I can't list the point there. Finally, it is asking us about the middle 40% of teachers. So I'm going to where my tail is, and then now instead of left or right, we are looking at the central part. And our area is also now 0.4. So this should give me two values as I'm looking at an in-between time. So going back down to execute, I've got that my lower percentile of the middle 40% is 17.4 and the upper is 22.6. So we can write between 17.4 17.4 hours and 22.6 hours.